On the morning of the 20th of August, 2014, a hurricane 1,000 kilometers wide formed in the sky above the North Pole, and not a single person on Earth could see it. It had spiral arms. It had a calm eye at its center. It rotated for nearly 8 hours. But it was not made of wind and rain. It was made of plasma, charged particles pouring down from space, and it went completely unnoticed until scientists dug it out of old satellite data years later. Now, more recent research has revealed something that should get your attention. A storm like this can scramble the GPS and satellite signals we quietly depend on every single day. This is not a doomsday story. It is stranger than that, because we can measure what this storm does to our technology far better than we can see the storm itself coming. To understand what happened, picture the morning of the 20th of August, 2014. Up at the edge of space, everything was quiet. The solar wind, the constant stream of particles the sun throws outward, was calm and slack. The sun's magnetic field was in a stable orientation, the kind that normally produces almost no space weather at all. It was, by every measure, an unremarkable day hundreds of kilometers above the North Pole. Nothing was supposed to happen. Then the sky whipped itself into a fury. Above the magnetic North Pole, a vast swirling mass began to take shape, a cyclone roughly 1,000 kilometers across. That is around 600 miles, wider than many of the hurricanes that come ashore on Earth. And it did not just resemble a hurricane in size. It had the whole anatomy, long spiral arms curling outward from the center, a calm, still eye at its core, a slow, steady rotation, turning counterclockwise, exactly like a storm you'd see on a weather map. It held that shape for nearly 8 hours. But here is the thing that makes it so strange to imagine. If you had been standing at the North Pole that day and looked straight up, you would have seen nothing at all. This storm was invisible to the human eye. It was not made of clouds. The only reason we know it happened is that 4 satellites from the United States Defense Meteorological Satellite Program happened to be passing overhead, carrying instruments sensitive enough to catch it. To the machines, it was unmistakable. To anyone on the ground, it simply was not there. A hurricane the size of a country spinning above the planet for 8 hours, and the world underneath it never knew. And its size is not even the strangest part. Here is the part I need you to hear clearly, because it is what turns a beautiful piece of space weather into a genuine puzzle. Storms in space are supposed to be violent weather events. They usually need turbulent conditions, a gusty, agitated solar wind slamming into the Earth to get going. That is when we expect trouble. Chaos up there produces chaos in our systems. This storm did the opposite. It appeared when everything was calm. The space environment that day was not just quiet, it was extremely quiet, precisely the kind of conditions under which almost nothing is supposed to form. And yet here was an enormous, energetic hurricane, pouring energy into the upper atmosphere during a period when the instruments said all was still. A storm that size should have needed a storm's conditions to build it. It had none. That contradiction is the first real mystery, and we will come back to how it resolves. The second strange thing is that nobody noticed. This event happened in 2014, but the world did not learn about it then. It sat quietly inside archived satellite data for years, unremarked, until a team of researchers led by Shandong University in China went back through the records and pieced it together. Only then did anyone realize what those 4 satellites had actually captured. In fact, before this analysis, scientists were not even certain that space hurricanes existed at all. This single observation was what proved they were real. So we have a storm that formed out of near-perfect calm and hid in plain sight for years before we understood it. We know it can happen. We are still catching up on what it is. And what it is exactly is where this gets stranger. Think about an ordinary hurricane for a moment. It is a storm of warm, moist air, spiraling around a low-pressure center, and it lives down here in the troposphere, the bottom layer of the atmosphere where all our weather happens, within a few kilometers of the ground. It is made of air and water, and when it turns, it rains. A space hurricane is almost none of those things. Strip away everything familiar. This storm does not form near the ground. It forms hundreds of kilometers up, in a region called the Ionosphere. That is the thin, electrically charged upper edge of our atmosphere, where the air is so sparse and so bathed in radiation from the sun that its atoms have been partly torn apart. It is the layer where the auroras glow. It sits far above where any normal weather could reach, and it is not made of air. A space hurricane is made of plasma. Plasma is what you get when a gas becomes so energized that its atoms break into charged particles, electrons and ions pulled loose from one another. It is often called the fourth state of matter, and most of the visible universe, including the sun itself, is made of it. So this storm is not swirling air, it is swirling electrically charged particles following the invisible lines of magnetic fields. And when it rains, it does not rain water, it rains electrons. The storm pours a downpour of charged particles down into the upper atmosphere, the very same process that lights up the northern lights, except here it is concentrated and organized into the spinning shape of a cyclone, a hurricane of plasma, raining electricity. But how do you build a hurricane out of charged particles in the first place? The engine behind this storm is not wind, and it is not heat. It is magnetism. The sun does not only send out the solar wind, it also carries its own magnetic field out into space, stretched across the solar system on that wind. We call it the interplanetary magnetic field, and the direction it points when it reaches us changes everything. Most of the big space storms we know about happen when that field points south. A southward field connects violently with Earth's own magnetic field, tearing openings that let solar energy pour in. That is the loud, turbulent kind of space weather. On that August day, the field was pointing north, and a northward field is normally the recipe for calm. But calm, it turns out, was the ingredient. Under those specific northward pointing conditions, something subtle happens high over the pole. The magnetic field lines from the sun and the Earth meet and reconnect, snapping and rejoining in a way that opens a direct channel funneling solar wind energy straight down toward the polar ionosphere. Think of it like water finding a drain. When the geometry lines up just right, all that energy spirals inward toward a single point, and the plasma begins to rotate around it. At the center, where everything converges, electrons rain downward in a concentrated column. That is the eye of the storm. So the quiet was never the absence of a driver. It was the one condition that let this particular driver switch on. The storm did not form despite the calm. It formed because of it. That is the resolution to the first mystery. A storm from a clear sky, built by magnetic field lines quietly reconnecting overhead. Which brings us to the question that matters most for anyone standing on the ground. Can a storm like this actually reach us? Here is a fair question. A storm made of plasma, hundreds of kilometers up, spinning over an empty stretch of the Arctic where almost no one lives. Can something that remote and that ghostly actually touch the technology you use every day? Until recently, we could not say for sure. Now we can, and the answer is yes. More recent research went back to that 2014 storm and measured what it actually did, and the findings are striking. Despite forming during those supposedly quiet conditions, the hurricane dumped an enormous amount of energy into the ionosphere, comparable to the energy deposited during a major geomagnetic storm. A quiet day at the instruments, and a superstorm's worth of energy pouring in over the pole. And that energy left a mark on our signals. As the storm churned the plasma above the pole, it created irregularities, patchy, turbulent regions in the ionosphere. And those irregularities did something specific to satellite signals passing through them. They caused strong scintillation in GPS and other satellite navigation signals. Scintillation is worth understanding plainly. Picture the way heat rising off hot tarmac makes the view above it shimmer and distort. The storm does the same thing to radio signals, making them flicker, wander, and degrade as they pass through the disturbed plasma. For a system that depends on a clean, steady signal from a satellite to tell you exactly where you are, that flickering is a real problem. Satellites flying through the region felt the geomagnetic disturbance directly as well. The storm was not a passive light show, it was actively reaching into the systems we rely on. So it can affect us, which raises an uncomfortable question. If it can do all that, why did no one see it coming? There's a reason this storm slipped past everyone, and it exposes a real gap in how we watch the sky. Our space weather warning systems are built around measurements of geomagnetic activity. Networks of ground stations scattered around the planet constantly track disturbances in Earth's magnetic field. And those readings get boiled down into the indices that tell forecasters whether conditions are quiet or stormy. It is a good system, but it has a geographic weakness, and space hurricanes fall straight into it. The problem is where those stations sit. The ground stations that feed our geomagnetic indices are located at latitudes below where space hurricanes form. These storms happen further poleward, right over the magnetic pole itself, in a region that sits beyond the effective reach of the monitoring network. So the indices can read calm, genuinely, honestly calm, while an intense, energetic storm is raging just poleward of where anyone is looking. The needle stays still not because nothing is happening, but because nothing is happening where the needle can feel it. The researchers said as much directly. They noted that our current geomagnetic activity indicators do not properly represent the dramatic activity inside these storms, precisely because the storms sit further poleward than the observatories that measure them. And this is not a one-off freak event. The same research found that these hurricanes tend to form near the magnetic poles in the summer months, which means they are a recurring feature of the polar sky, not a single accident of 2014. Put those together and the conclusion is uncomfortable. There is an entire category of space weather, energetic enough to disrupt our signals, that our warning systems have been effectively blind to. And that blind spot is exactly what the more dramatic corners of the internet have run much too far with. You may have seen the more dramatic version of this, and I want to be fair to it because it starts from something real. The framing online tends toward alarm. A terrifying new storm discovered above our heads, an invisible threat about to knock out GPS across the world, take down power grids, a danger science somehow missed until now, often with the strong implication that we are all in immediate peril. The kernel underneath that is not nonsense. These storms genuinely do disrupt satellite signals. They genuinely do inject serious energy into the upper atmosphere, and our monitoring genuinely does miss them. Those are real findings, and I just walked you through them. But the leap from there to global catastrophe does not survive contact with the details. Start with where these storms live. A space hurricane is a localized, high-latitude phenomenon. It forms over the poles, in a specific region, under specific conditions. It is not a planet-wide event, and it is not poised to knock out navigation for everyone on Earth. The 2014 storm caused regional disruption to signals passing through the polar ionosphere, not a worldwide blackout. And here is the crucial point that the doom framing gets backwards. These storms are newly understood, not newly occurring. They have almost certainly been forming over the poles for a very long time, quietly, throughout the entire era of GPS, without anyone noticing catastrophic harm. What changed in 2014 is not that the storms began, it is that we finally caught one and understood it. So the honest residual is not an apocalypse with a countdown. It is a genuine gap in our monitoring, meeting a world that leans on these signals more every year, which is exactly why this should matter to you. There's a practical reason this discovery matters far more now than it would have 20 years ago. It comes down to how much of ordinary life quietly runs on those satellite signals. Most people think of GPS as the little arrow on a phone map. It is so much more than that. The same satellite navigation signals guide aircraft and ships, steer the machinery that plants and harvests our food, and timestamp financial transactions down to fractions of a second. They even carry the precise timing pulses that keep power grids and communication networks synchronized. When those signals flicker, the effects reach far past a wrong turn on a road. And look at where these storms strike. They form over the poles, and the polar regions are exactly where a growing number of flights and high-latitude operations now pass. Routes that thread directly through the part of the sky where these hurricanes appear. A category of space weather that we currently struggle to see coming, hitting precisely the region our aircraft and systems increasingly rely on, is a real vulnerability, and it grows as our dependence deepens. There is an upside, though, and it is the reason discoveries like this matter. Now that we know these storms exist and understand what they do, we can begin to build the monitoring to catch them. Every study of that 2014 event sharpens the picture and tells us where to point our instruments next. We are slowly learning to see a thing that was invisible to us just a few years ago. But we are not there yet. We can measure the fingerprint this storm leaves on our signals far better than we can see the storm itself gathering. That gap is the real story. A 1,000-kilometer hurricane, spinning silently over the pole, that the world beneath never felt, and that we are only now learning to watch for.